Welcome to the Deep Dive, the place where we turn massive stacks of industry news and technical reports into pure, concentrated knowledge tailored just for you.
If you thought the holiday week between Christmas and New Year's was going to be quiet and AI, well, you missed one of the most aggressive strategic power plays we've seen in a long time.
I mean, it was anything but quiet. We're looking at the period from December 28th, 2025 to January 4th, 2026. And it was it was defined by this incredible consolidation of control.
Absolutely. We're talking about a single week where one company deployed over, what, $25 billion in capital?
Over $25 billion. And the theme is so clear. It's not about just selling chips anymore. The whole idea is building the entire AI factory ecosystem.
From the ground up, controlling everything from the physical power grid all the way to the software that simulates the world.
So the mission here is basically total dominion.
That's it. And the money they spent this week, it had two jobs. First, neutralize your immediate competitors. And second, put technical demands on the supply chain that are so high, so expensive, that almost no one else can even play the game.
Okay, let's unpack that. We have to start with the money, with segmenting strategic partnerships and funding, because this spending spree really tells the story.
It does. And we begin with a $5 billion handshake, a deal that basically forced a partnership with a longtime rival.
Right. This headline was all over CNBC and the Register on December 29th. NVIDIA finalizes $5 billion investment in Intel.
So this was the final step in a deal announced a few months back. They completed the purchase of 214.7 million Intel shares. The price tag, as you said, was $5 billion.
And that gets them, what, about 4.4% ownership of Intel?
Roughly 4.4%, yeah.
So why does that matter? It's not a controlling stake. This isn't a takeover.
No, it's not a takeover. It's, you could say, a forced collaboration. The real value here is getting Intel to design custom CPUs that are specifically optimized for NVIDIA's NVLink. It's about gluing the architectures together in the data center.
So you can't have these foundational pieces fighting each other.
Exactly. It ensures everything's in sync. It also guarantees a market for their connection tech. So you remove a huge potential bottleneck.
Okay, that makes sense. But that was just the start. Truly, I mean, the market-defining move was next. A staggering $20 billion play aimed squarely at speed.
This is the Groq deal. We saw reports breaking all week, especially from CNBC, detailing the finances of NVIDIA licensing Groq inference tech in a $20 billion deal.
$20 billion, that is their largest transaction ever. So what did they get for that much money? Especially when you remember Groq was valued at less than $7 billion just a few months ago.
Well, on paper, it's a non-exclusive licensing agreement for Groq's inference technology.
Yeah.
And inference, is all about speed, how fast the AI gives you an answer. Groq was a real disruptor there.
But the real move wasn't just the tech, was it?
Not at all. The masterstroke was the acqui-hire. The deal also brought over Groq's founder, Jonathan Ross, their president, Sunny Madra, and about 90% of their most valuable employees.
90%. That's the detail. So they licensed the IP, meaning others could technically still use it, but they took the brains behind it.
Precisely. And some critics are calling it strip mining for a reason.
How so?
Because the structure seems designed to get that critical IP and talent. And Ross was a key architect on Google's TPU while avoiding the kind of intense antitrust review that a full acquisition would trigger.
So they get what they want, inference dominance, and they neutralize a competitor without all the regulatory headaches.
That's the strategy.
Yeah.
And it means anyone else who tries to license that Groq IP later won't have the people who actually know how to make it work at its peak.
Wow. So the takeaway is that in AI, the human talent is now valued at 3 times the actual company. That sets a worrying precedent for other startups.
It absolutely does. It changes the entire game.
And moving from finance to the factory floor, they also expanded their work in physical automation.
That brings us to the Siemens partnership on AI-driven manufacturing sites. This is where that whole AI factory concept becomes, a physical reality.
So what's the goal with this expansion?
It's all about what they call physical AI. They're using the Siemens factory in Erlangen, Germany, as a blueprint to build fully AI-driven sites. And the key is they're using NVIDIA Omniverse to create active digital twins.
Active digital twins, that sounds like a huge leap past just a simple simulation.
It is. These aren't just models. The twins autonomously test out improvements, and then, and this is the crucial part, they implement changes directly on the real-world shop floor. No human needed.
So we're moving from robots doing single tasks to an intelligent system that manages and optimizes itself.
That's exactly it. It's a full-scale industrial overhaul.
Which makes perfect sense. If you're dictating how the software runs the factory, you're also going to dictate the physical hardware inside it. Let's jump to segment C, chips and infrastructure. This is where the strategy gets very real.
And the first mandate is a big one. We saw this in executive snapshots, later picked up by the Register. NVIDIA mandates 16-layer HBM for next-gen Rubin platform.
HBM, high bandwidth memory, that's the superhighway for data getting to the GPU. So why is jumping to 16 layers such a huge technical challenge?
Because it's not just another small step, it's a revolutionary demand. To stack 16 layers of memory and keep the chip a usable size, the suppliers have to thin each wafer down to about 30 micrometers.
30 micrometers. What's the comparison point for that?
Well, the current high-end designs use 50 micrometers, so this is a massive reduction. We're talking thinner than a human hair.
And what is forcing that kind of thinness due to the manufacturers?
It forces them into extremely expensive, very complex new processes. The consensus is that it probably means they have to move to something called hybrid bonding technology. So NVIDIA is basically forcing a multi-billion-dollar capital investment onto their own suppliers.
Just to get ready for the Rubin platform.
Exactly. It ensures only the biggest and most compliant partners can even deliver. You choke off competition before the product is even out.
And while they're overhauling the chips, they're also overhauling the factory itself. We saw that in the 800-volt direct current, or DC, for their data centers.
Yes, this is a radical but totally necessary shift. They're moving to 800-volt direct current, or DC, for their data centers.
Why? What's the benefit of doubling the voltage from the usual AC power?
It's just basic physics, really, but with huge savings. When you double the voltage, you cut the current in half to get the same amount of power. And since energy loss, the heat you waste is based on the square of the current.
You reduce that loss by a factor of 4.
A factor of 4. It allows for power densities over 1 megawatt per rack. And on top of that, you use 45% less copper for your cabling.
So it's not just an efficiency gain. It's a massive cost saving on cooling and materials. It's what makes these gigafactories financially possible.
And partners are already lining up. That's the last piece here, the January 4th announcement from Lenovo, the Lenovo AI Cloud Gigafactory program with NVIDIA.
And what's unique about that program?
It's all about getting these gigawatt-scale factories deployed faster. Lenovo is bringing its Neptune liquid cooling tech and integrating it with NVIDIA's platforms.
So like the GB300 system?
Exactly. The GB300 NVL72, that's 72 Blackwell Ultra GPUs and 36 Grace CPUs, all in one rack. And it's fully liquid cooled from the start. When you're pushing a megawatt per rack, liquid cooling isn't a luxury, it's a requirement.
So the foundation is set, the power, the cooling, the physical demands. Now let's talk about the AI that runs on it. Segment A research and physical AI models.
Right. If you want to build active digital twins, you need models that actually understand physics. And that's where we saw details on the Cosmos Predict 2 World Foundation models.
What's their main job, these models?
They're built for physical AI. Cosmos Predict 2 is a family of models. They come in 2 billion and 14 billion parameter sizes. And they generate physics-aware images and videos. The whole point is to close that sim-to-real gap.
Making sure what you train in simulation actually works in the real world.
Precisely. And the key feature is what's called the action condition model. It lets a robot predict, for example, 12 future video frames based on 12 gripper actions it plans to take.
So it's moving from just reacting to actually planning ahead.
Exactly. It's about foresight, which you need for any kind of complex task.
And to run all those simulations, you need the right software.
Which brings us to Warp. On January 2nd, we got Warp v1 Mono 1 released with multi-world spatial queries. Warp is their C8X library for accelerating physics simulations.
And the key update was multi-world spatial queries. Why is that important?
Well, for training, you'll often have a single GPU simulating thousands of independent worlds or scenarios at once. These group-aware queries let the system do things like check for a collision inside just one of those worlds without wasting time looking through all the data from the thousands of others.
So it's a huge efficiency boost for training at massive scale.
A massive boost.
Okay, and finally in the model segment, there was something new on the collaborative agent front.
Yes, the Neutron 3 nano operational details were published. This is their 30 billion parameter model, and it's confirmed to be open weight, which is important.
And its focus is on multi-agent systems.
Right, where you have several specialized AIs working together on a task. The really interesting part is a developer toggle, a switch for reasoning OF.
So you can choose between speed and depth?
That's it. You can prioritize deep reflective thought when you have time, or you can switch to fast, low-latency responses when speed is everything. It's that kind of flexibility you'd need in a real-time factory environment. It all connects. Okay, let's shift to how this tech shows up for consumers and in our security.
Segment B, and we have the GeForce NW January 2026 update adds Blackwell support. This dropped on New Year's Day.
And the big news is obviously the new Blackwell architecture, the RTX 5080, making its way into their cloud gaming service.
Right, which means gamers on the ultimate tier get the latest AI features, like native DLSS 4 support. And the big headline number is 5K resolution at 120 frames per second streamed.
So a very quick pipeline from new silicon to public cloud.
Very quick. And on the audio side, there was a big step for analyzing conversations in real time.
Ah, the diarization model.
The streaming sort-former speaker diarization model was updated. It now uses something called arrival order sorting to keep track of who is speaking in a live conversation.
And how much better did it get?
It hit a new state-of-the-art score, a diarization error rate, or DER, of 13.24 on a really tough benchmark. A lower number is better, and for a streaming system, 13.24 is a breakthrough. It makes voice agents much more reliable. And speaking of reliability, if you're running these massive AI factories, security has to be front and center. What happened in Segment D?
On January 2nd, the reference design guide for DPF Zero Trust was published. It's a guide for implementing zero trust networking using their Bluefield 3 DPUs.
DPUs, data processing units. Why offload the security to them instead of the main CPU?
It's all about saving your most valuable resources. By having the DPU handle security tasks like encryption and authentication, you free up all the CPU and GPU cycles for what they're meant for, training the AI models.
So you get top-tier security without any performance hit on the actual AI workload.
Exactly. For a multi-tenant AI cloud, that kind of isolated security architecture is non-negotiable.
And just to wrap it all up, one last data point that shows the incredible global demand for all this hardware.
Yeah, an executive summary this week highlighted a $160 million smuggling bust involving these chips.
160 million?
It just reinforces the artificial scarcity that's driving all of this. It's a grim reminder of how critical this hardware has become on the world stage, legally or not.
Okay, let's put it all together. When you look back at all 13 points, what does this week really tell us?
It was about consolidation. It was about future-proofing. That $25 billion secured talent and IP with a Groq deal for inference, and it forced collaboration with the Intel investment.
And at the same time, they just rewrote the physical rules of the game. The 16-layer HBM mandate for Rubin raises the technical bar for the whole supply chain.
And the 800V DC power architecture just makes it all possible at scale. So the whole structure is now in place. For the money, to the physics, to the software, like the Cosmos models that will run it all autonomously.
It's a fully integrated ecosystem. There's very little oxygen left for independent competitors.
That's it. This quiet holiday week was actually the most aggressive phase of market control we've ever seen. It feels less like R&D and more like the full-scale industrialization of intelligence.
That's the perfect way to put it. They are defining the entire supply chain, from the thickness of a silicon wafer to the cognitive models a robot uses.
Which leaves us with a really critical question for you, the listener, to think about.
We just saw NVIDIA spend $25 billion in a single week to acquire technology and lock down its manufacturing pipeline. When the price of entry to compete in AI hardware is now in the tens of billions of dollars, what chance does a truly independent innovator actually have?
And if the main path for innovation now is to be absorbed through these kinds of deals designed to capture talent while sidestepping antitrust, what does that really mean for the long-term health, diversity, and even the security of the entire global AI supply chain?
That is something to mull over. Thanks for diving deep with us.